Okay guys, today we're learning how to factor the sum or difference of two cubes. Okay, so we had this difference of squares rule before, which said if we could write something as the difference of two perfect squares, that we could factor it like this. A squared minus b squared equals a plus b times a minus b. That was the rule. So here's what I want you to do. Quickly go through A, B, C, and D here. Factor them using difference of squares rules if you can, and if you can't, write prime. Pause and then come back. This should be a review. Okay, I'm assuming you've done that. This we could rewrite as x squared minus 4 squared. So we can factor it to x minus 4 times x plus 4, or the other way around. B has a 5 in front of it. It's prime. We can't deal with that with a 5. C, 3x times 3x is 9x squared, and 8 times 8 is 64. So this is a difference of squares rule, which we can write as 3x minus 8 times 3x plus 8. And lastly, this one's prime. It's got a plus sign in it. We can't do binomials that way. Sorry. So we're going to have a very similar thing today. The sum and difference of cubes rule says this: a cubed plus or minus b cubed is equal to a plus or minus b times a squared minus plus ab plus b squared. Now you might be wondering why there are two symbols. Really, it's just to prevent us from writing two different formulas. There are two different formulas here. The sum of cubes rule, which says use all the top symbols and you get a formula, and the difference of cubes rule, which says use all the bottom symbols and you got a different formula. So that last symbol is always a plus, but basically it means if you're adding two cubes, you're going to use a plus, then a minus, then a plus. If you're subtracting two cubes, you're going to use a minus, a plus, and then a plus. Use it in the exact same way as the difference of squares rule. Okay, so if it's addition, use the top symbol, subtraction, use the bottom. Here's how this is going to work. We could rewrite 8x cubed as 2x times 2x times 2x, or 2x cubed. We could rewrite 1 as 1 cubed. So my a is 2x, and my b is 1. So I can rewrite this. I'm using my bottom symbol since it's subtraction, a minus b, 2x minus 1, times a squared, so 2x times 2x is 4x squared. We're still using bottom symbols, plus a times b, 2x times 1 is still 2x, plus b squared. 1 squared is 1. Go ahead and multiply this back out if you feel like checking your answers, but we are going to get 8x cubed minus 1 when we multiply things back out. B is where things get a little bit tricky. How do we rewrite x to the 9th as a cube? That's x cubed times x cubed times x cubed, or x cubed cubed. 27y cubed, that's 3y times itself 3 times, or 3y cubed. This time we're using the top symbols. So we're first supposed to do a plus b. My a is x cubed. My b is 3y. Then a squared. So x cubed times x cubed, that'd be what it is squared, or x to the 6th, there's 6 x's. A times b, 3x cubed y. Oops, that was supposed to be a minus, sorry. And then plus b squared, 9y squared. Woohoo! Go ahead and try the next two on your own. I'll give you a hint. One of them is prime, and one of them looks prime, but it actually isn't. Pause and then come back. Okay, I'm assuming you've done that. C is the one that's prime, guys. There's no way to write 2x cubed as something times itself 3 times because of the 2 there. D looks to be the same way until you realize the first step in any factoring problem is checking for a greatest common factor, which hopefully you did. So this becomes 2 times x cubed plus 8. X cubed and 8 are both perfect squares. X cubed is obvious, and 8 is 2 cubed. So my a is x, and my b is 2. Use the top symbols. A plus b times a squared minus a times b plus b squared. Hopefully you got that last one right. That was definitely a tricky one. That's it for this video. Make sure you're checking for GCFs every time you factor.